Today we're going to be reviewing the properties of similar figures. So there's three properties or three attributes of similar figures, meaning in order for two figures to be similar, these three things must be satisfied. One, they have to have the same shape. So write this down right underneath there. Same shape. Two, they have to have congruent corresponding angles. So when we talk about congruent, this word congruent means the same. The word corresponding means the ones that match or belong together. So we're talking about angles that are the same and that either match or they belong together. And then three, the ratios of their side lengths must be equivalent or proportional. Now, I know that third one, the ratios of their side lengths must be equivalent or proportional. That sounds like a lot, but I'm going to show you using the math exactly what we mean by that. So here we're going to look at two similar figures. I don't know why it's not allowing me to turn these. It's a little crooked, so forgive me for the crookedness. It says similar figures have this same shape but different size. That was the first thing that we talked about, the first attribute that we must satisfy in order for two figures to be similar. First thing we're going to do, this problem here is asking us to find the missing side length JK. Now first, let's talk about the corresponding congruent angles. Now I want to know and look at the shapes to figure out which angle from the second shape corresponds with angle F. And I'm using red to show you angle F and angle J correspond with each other. Same for angle G. I want to know from the second shape or the smaller shape which angle corresponds with G, and that's K. I use green to show you which ones correspond or match. And then for the last one, I'm going to show you using blue the angle from the smaller figure that corresponds or matches or belongs with angle E, and that's angle H. So we can see which angles correspond. Now that I know which angles correspond, I'm going to draw the smaller shape inside of the larger shape. Forgive my drawing, it's not that great. And then I'm going to label the angles that correspond. I know J and F correspond, so I'm going to put the J here. I know K and G correspond. I'm going to put the K there. And then I know H and E correspond, so I'm going to put the H there. Once I fill in the angles, I'm going to fill in the measurements or the numbers that we know. I know that JH here corresponds with FE. I know those two sides correspond, so I'm going to make sure that I fill in the 3.5 here. And then our question mark, we're going to call that X. And I know that JK here, it corresponds with FG. So I'm going to fill in this question mark here, but instead of a question mark, I'm going to put an X, right? I don't know what happened there. We're going to put an X there. Now that we have the figures drawn inside of each other, it's going to enable us to pull ratios from these shapes. And you're going to see how we use the ratios to find the missing side JK, to find that X there. First, I'm going to take the ratio 10.5 to 3.5. And then I'm going to take the ratio 21 to X. We're going to put those ratios into a proportion, and we're going to solve to find X. So before I do anything, when I described this ratio 10.5 to 3.5, we went from the big shape to the small shape. So we're going to label our ratio big to small. And then when I write it, I'm going to write it big to small. So 10.5 was from the big one, 3.5 was from the small one. And then I need an equal sign. And then I'm going to do the same for this 21 to x. We're going to go from 21 to x because that's from big to small. Next step, we're going to cross multiply. 10.5 times x is 10.5x equals 21 times 3.5 is 73.5. I have a one-step equation now. I'm going to divide both sides by 10.5 so that we can determine the x, which is 7. Now x equals 7, which means this missing side length here, this jk on our smaller one, that is 7. Let's review what we did. We found the corresponding angles, the angles that matched up or belong. We know that angle F from the big one, angle F and angle J corresponded. We found that G and K corresponded. And then we found that E and H corresponded. Once we knew which angles corresponded, we drew the small one inside the larger one. So we drew the small triangle here inside the larger one. We made sure that the angles matched up the way that they were supposed to. Next, we wrote in the numbers. After that, we found ratios. So we took this first ratio, 10.5 to 3.5. We went from big to small. The next one, we took the second ratio, 21 to x, big to small. We wrote it in a proportion. We labeled it big to small, and then we solved for x. Next up, we are going to find the missing side PO here. We have two polygons, and we're going to find out what the measurement for the side PO is. Remember, we have to figure out which angles correspond with each other first. So if I'm looking and I'm trying to figure out, I need to know which angle here corresponds with, so which angle from the smaller shape corresponds with U. And if we were to turn that smaller shape, we would see that angle P and angle U correspond with each other. Same with V. We have to see which angle corresponds with V. I know that Q corresponds with V because P and Q, this is the long side here, and this is also the longest side. So that's how I know that those two angles correspond. And then, of course, we need to know which angle corresponds with S. I can tell that that's N. And then, last but not least, I need to know what corresponds with T, and that's O right here. So now that I know which angles correspond, I'm going to draw the smaller one inside of the larger shape. Right? Excuse my crude drawing. And then we're going to label the angles. P, Q, O, N. Then we're going to fill in the numbers that we know that go. So I know that O, N is 6. And then I know that our missing side, or our X, is going to be P to O. And then from there, we need to find ratios so that we can create a proportion and solve the proportion. First of all, you need to make sure that you include your X into the ratio that you're choosing. This time, I'm going to go from small to big. So we're going to label our proportion small to big. And then I know that we're talking about X to 12, because X is from the smaller shape, 12 is from the larger shape, or the bigger shape. And then I can take this one as well. We're going to go, this ratio here is small to big, 6 to 14. Next step is we're going to cross multiply. So X times 14 is 14X, equal to 12 times 6, which is 72. Next step, we're going to divide both sides by 14, and we get X is equal to somewhere around 5 14/100. Now that we know how to solve to find the missing lengths, we're going to just look to determine if two shapes are similar, right? So let's say we have these two triangles here, and these are two right triangles. And we need to determine if these two are similar figures. So I'm going to put in the measurements. Let's say this is 5 and 10. And then let's say this was 1 and 2. And we need to determine whether these figures are similar or not. Well, if you remember back to the rules for similar figures, 1, they have to have the same shape. 2, they have to have congruent corresponding angles. And then 3, they have to have side lengths that are proportional. Excuse my messy handwriting. So again, all we're going to do is we're going to figure out if these two are similar figures. We're not solving to find x, we're just seeing if they're similar. Again, I'm going to draw the smaller one inside the larger one. So I'm going to draw the small one in here. And then I'm going to fill in the numbers or the measurements. So this would be 1. Oops. This one here would be 1. This would be 2. And then we're going to take ratios, right? So I'll take this ratio, 1/5. We went from big to small. I'm sorry, small to big. Small to big. 1 to 5. And then we're going to take this one over here, and we're going to go small to big, 2 to 10. Again, we're not solving to find x. We're just trying to see if they're similar. And the way that we determine if they're similar is if we take the two ratios and they're equivalent, then that means they're similar. So here I'm going to cross multiply. 2 times 5 equals 10. 1 times 10 equals 10. They are similar. Now, let's say that one of these, let's say when I multiplied, I did not get the same number. Let's say this was 12, and the other one when I multiplied was 10. That would make them not similar because they would not be proportional. So let's just kind of wrap up what we learned. We learned the 3 rules of similarity. 1, they have to have the same shape. 2, they have to have congruent corresponding angles. And 3, they have to have side lengths that are equivalent or the ratio of their side lengths have to be equivalent or proportional. The trick to this when you're trying to solve to find the missing side is to draw this, to identify the congruent corresponding angles, draw the small one inside the big one, take the ratios out, create a proportion with the two ratios, and then solve, cross multiply, and solve a one-step equation.